Okay. All right. So down here at the very, very bottom, okay, let's just look at this last sentence. So we talked about the fact that polynomials, right, they're smooth and continuous, but then we also talked about behavior on the ends, on the end behavior. So it turns out you can predict all kinds of stuff about the graph if you know what to look for in the equation, okay? So when we talk about end behavior, which is what we're just about to talk about, okay, we're talking about what's happening on the very, very far right and the very, very far left. Okay, we call that end behavior. So that's what we're talking about. All right, so now we're going to start on page 9. Just wanted to make sure we went over that. Okay. All right, so jump right in. So here's the deal. Okay, if the function, of course you're the wrong other direction. Okay, so if the function is rising on the ends, okay, either the far left or the far right, we say it rises right or it rises left. That's what we call it when it goes up. We don't just say goes up, we say rises right or rises left. All right, if it's going the other direction, if it's going down on the ends, we say it's falling. So we say falls right, falls left. So just be comfortable using the words rises and falls instead of up or down, because that's kind of what you're going to start hearing a lot. All right, so how do we figure this out? We use something called the leading coefficient test. This is going to tell you what's happening on those ends. Now, we don't know what's happening in the middle, okay? Not yet. We're going to learn that in the next couple of pages. But right now, the middle is a mystery. But you're going to know what's happening on the ends, if it's rising or if it's falling. Here's how. First, you're going to look at the leading coefficient, right? That's the number in front of the biggest exponent term. If your leading coefficient is positive, it's rising on the right. If it's negative, it's falling on the right. Okay? So leading coefficient determines the right-hand side. The degree determines the left-hand side. If the degree is even, like a 2 or a 4, something like that, it's the same behavior that's on the left. If the degree is odd, like 1, 3, 5, something like that, it's the opposite behavior on the left. So notice you have to find the right behavior first, because you can't just go to the degree and look at it and determine the left-hand behavior, because all the left-hand behavior is going to tell you is same. Well, same as what? Or opposite? Opposite of what? You know, you don't know. So that's why you have to determine the right-hand behavior first, then determine the left. So we're going to look at leading coefficient first, and then we're going to look at degree second. I did not even see Priscilla leave. I just thought she just slid right under her desk, and she's gone. Yeah, that's super weird. Okay, all right, here we go. So let's look at just this. This is a super easy one. We're going to start off easy. It's just x squared. That's a parabola. So even if we don't know this information, in our mind, we know what it should look like. What should x squared look like? Yeah, a parabola that goes up, right? Should look like this. Okay. Well, let's see if this test really holds true. Okay. So first thing we have to find is the leading coefficient. Well, turns out our leading coefficient, is it positive or negative out in front? Positive. So a positive leading coefficient does what on the right? Rises. So it's going to rise on the right. This is because these are all leading coefficient questions over here. Okay. All right. I know. I don't know. I'm just make it difficult. Okay. Then here's all the left. So these are going to be the degree situations over here. Okay. So we determined it's rising because we have a positive leading coefficient. Then we look at the degree. What's the degree of our poly? 2, and he's even. That means the same thing is happening on the left. So what's happening on the left? It's also rising. And sure enough, that is what's happening. They're both rising. Okay, so let's talk about that again. Okay, so positive leading coefficient means rising to the right. Even degree means same behavior on the left. So since it was rising right, it's also rising left. Does that make sense? Okay, let's try another one. Let's try this little guy. Same thing, but now he's negative out front. Okay, first thing we have to do is leading coefficient. So if he's negative, what's going to happen to the right? He falls to the right. That means we're falling to the right. Okay, then I look at the degree. It's 2. That means same behavior is going to happen on the left. So what's going to happen on the left? It's also falling. So it turns out he looks like that, right? He's a parabola that's opening down because he's got a negative leading coefficient. Okay, let's look at this guy. All right, we'll get a little more complicated in a little bit, but let's look at him. He's just x cubed. Okay, I don't know if you know what a cube looks like. He's that curvy mountain road, right? Okay, so leading coefficient is positive. So what's happening on the right? He's rising. Okay, so over here on the right, he's rising. Okay, then my degree though is odd. So an odd degree means the opposite behavior on the left. So if I was rising on the right, what am I doing on the left? Falling, I'm fall. So that means this little guy here, he was rising to the right, but then he's going to make a direction change and fall to the left. That belongs to him. That's what he's going to look like. I don't really know what's happening in the middle, but I know he's rising on the right and he's falling on the left. Okay, let's try last one of these here. Negative x cubed. Okay, so my leading coefficient is negative, which means what happens to the right? Falls. Okay, so I'm going to come over here and I'm going to say he falls to the right. I just drew him down here. Okay, then my degree is odd, which means opposite behavior on the left. So what's happening on the left? He's going to rise. And he's going to end up looking like that. Okay. All right. So does that kind of make sense there then? So I think it's kind of self-explanatory to think about if it's positive, you're rising. If it's negative, you're falling. But you have to remember that's for the right. Then for the left, odd, opposite, right? They're both O's. And then the same would be the even. Okay. All right, so let's try this down here. All right, knowing what we know then, let's see if we can match these little graphs here. Okay, let's label these graphs because it'll be easier. Let's just make them A, B, C, D, okay? And let's see if we can figure out who goes with who, because this is right out of my math lab. All right, these are a little more complicated polys, so let's take our time here. All right, first of all, I'm looking at number 1. He's already in descending order, right? I have the biggest exponent, then the smallest exponent. So I actually don't even need this stuff in the back. All I'm interested in is that very first term. That's the only thing that matters for this test. So if I'm looking at negative x to the 4th, this negative tells me what? I'm falling, but am I falling left or falling right? This means falling right because of this, right? Okay, your leading coefficient tells you falling right. Okay, then when I look at the degree, because it's a 4, that's even, what's going to happen on the left? Same thing. They're both falling. Now you don't have to write this if you don't want to. I just wanted to make sure that we were clear on it. All you have to write is A, B, C, or D. So which graph is it going to be that falls left and right? C. I'm falling to the right and I'm falling to the left. I don't know or care what's going on in the middle yet. That comes later. Okay, good. All right, let's look at our next one. So he's in descending order. This is the biggest exponent, so I really don't need the other guys right now. I'll use them for something else later. So if I'm looking at my leading coefficient, he's positive. That means I'm going to be rising right. Leading coefficient tells you on the right. Then I look at my degree, odd. Odd is opposite. So what's happening on the left? Falling left. All right, so I need a rises right and a falling left. Okay, I've got a rising right and a falling left. There we go. Perfect. Okay. All right, we got a big long one here for number 3, but do we need all of those terms? No, we really don't. This is not really of interest to us right now. It will be later, but not right now. Okay, so I look at my leading coefficient and he's negative. So we're going to be falling right. Okay, then I look at my degree and it's odd. Odd is opposite. So if I was falling right, I'm going to be rising left. Okay, what do we think? All right, of course, 4 has to be D, but let's look at why, because this is a strange little situation here. Now we have a packet, right? Yeah, now you don't have to FOIL. We're going to use the little shortcut there, right? We're going to look at our leading coefficient, which is just out in front of the packet. We're just looking right out in front of the packet, and he's positive. So we're going to be rising right, okay? And he's got an exponent of 2 out here. So that's going to be the same. That's going to be rising left. And of course, that's D. That would be an example of a parabola that's opening up. Okay. Does that sound okay with everybody? All right. These are right out of my math lab, all 4 of these. Okay. We good if we switch? Okay. Okay, just 4 more little examples of these, and then we'll get into the middle, figuring out what do you know about the middle. Okay, here we go. So I know this is kind of hard to see, but it's negative x to the 8 plus x to the 6. That's what that's supposed to be. Okay, the directions say use the leading coefficient test to determine the end behavior of the graph and then match your graph. Okay, so we really don't even need the plus x to the 6. We're only looking at negative x to the 8. Okay, I notice his leading coefficient is negative, so we are going to be falling right. Okay, well that kind of gets rid of B and D, right? Because they're not falling right. Okay, then I look at the exponent, it's even. An even exponent means the same thing's happening on the left. No, same thing, so falling left, right? Same thing, and that's going to be C. Okay. All right, is everybody okay with how to figure this out? Doing all right? Okay. All right, let's try another one. So now we have one of those situations where we have the packet with the exponent, just to check you. All right, so I'm looking out front. I don't see anything at all, so it must be positive. So that means we're going to be rising right. Okay, well then we're going to get rid of, let's see, D. Oh, nope, I'm sorry. We're going to get rid of B and C because they're falling to the right. So it can't be those 2. Okay, then I look at my exponent, the 6, it's even. So that means the same thing's going to happen on the left. So we're also rising left. Okay, now we have a little bit of an issue. Okay, now you can see that sometimes this is not enough to figure out what's happening because you all really need to know the middle also. All right, so both of these guys are rising on the left and the right. So this is kind of a preview and how to figure out what's going on. Let's look at the x-intercepts. If I look at the x-intercepts here, I have x is -1 and I have x is 3. I look at the x-intercepts here, and I just have x is 1. Okay, now remember, x-intercepts are solutions to the equation. They're the answers. So if you had this guy, he's already factored for you, and you were to set him equal to 0 and solve, I'm not worried about the exponent out in front, or I mean up on the side there. X equals 1 would be a solution, his only solution. So it's A. Okay, that's just a little preview in how to tell what's going to happen in the middle. So what this means is there's 6 of those packets, and every single one of them looks like this. And if you were to set it equal to 0 and solve, you would get x equals 1. That's the only solution to this. So it's got to be A. Okay, does that make sense? It's a little weird, but we're going to get there in just a minute. I just kind of wanted to show you that sometimes it's not as easy as the end behavior. Okay, let's go back to some straightforward ones. These are what you're going to have on the test. So you're actually going to have to read words. I know it's hard. Okay, so this is what you'll see on test 3. All right, so it's already in descending order. I see our biggest exponent is 7, so I really don't need these guys back here. Okay, then I'm going to look and see I have a leading coefficient that's positive. Now it doesn't matter that it's 4, it just matters that it's positive. So I'm going to be rising right. Okay, and there's only one that rises right, so it's got to be this. But if we keep going, the exponent is odd, which means opposite. So we are falling left. Okay, it's got to be that guy. All right, let's try the last one here, and then we'll look at some middle stuff. Okay, so we're in descending order. I see that. Okay, get rid of that stuff. All right, my leading coefficient is a -5. The 5 doesn't matter, but since it's negative, it's going to be falling which direction? Right. You always have to find out the right one first. Okay, then you look at the exponent. It's even, which means the same thing is happening on the left. So it's got to be, I'm looking, C, sorry. All I could hear was A because I'm old. Okay, so C. All right, there you go. All right. Leading coefficient test good. Pretty straightforward, not too bad. Okay, they're both falling. Got a negative leading coefficient and an even exponent. Even exponent means same thing on the left. That's what that means. So that's why they're both falling. Oh, and my polish is off. I know. And then look at this. It looks like I've been in a fight. So we have a kitten named Schmoopy. Schmoopy's not quite so schmoopy. Schmoopy's kind of the devil. And so I desperately want to love Schmoopy, like love him and kiss him and call him my own. And he's like not having it. And so sometimes we have some disagreements. Yeah. Schmoopy did not want to be held and rocked to sleep. I tried. But yeah. Schmoopy. Yeah, so Rhiannon's our neighbor, so I'm sure she can hear me out in the yard at night going, Schmoop, Schmoopy, Schmoop. I would sound like a complete idiot, but I yell it anyway, and you know, he comes, but he just doesn't want to be touched. All right, here we go. All right, so that's the end behavior. So then we have the middle. The middle behavior is multiplicity. Okay, middle is multiplicity. That's what we're talking about. And some students get really confused by that word because it's not a word that you hear very often. So let's talk about it. All right, well, let's forget it for just a second. We'll come back to it. Okay, first, remember that the x values where this equals 0, these mean the solutions. We sometimes, well, you're used to calling them the answers. So they're used to being called the solutions. But in higher math, we sometimes call those the zeros because they're the x-intercepts. So they're where y equals 0. Sometimes we also call them the roots, and I'm not sure the history behind that, but sometimes we call them the roots. They mean the zeros or the solutions. They're also your x-intercepts on the graphs. So that's really important. So you can find the end behavior, then you can solve it and find the answers, and those are your x-intercepts. Okay, the multiplicity of the zero or the solution or the answer is the degree of its factor. This means the exponent on the packet or how many times it's a zero. So if we go back to that weird situation back here, I'm trying to leave that so you can copy it, but right here where we had x equals 1, its solution is 1. Its zero is 1, but its multiplicity is 6. That's the exponent that was on the packet. That's how many times it's a zero, okay? So it's either the little exponent on the packet or it's how many times it's a zero. This is important because it tells you what happens at the solutions. It tells you what's going on in the middle. So you have your end behavior, you have your x-intercepts, but what's going on at the x-intercepts? The graph could be coming down to the x-intercept, touching and turning, like a parabola. It's a touch and turn, a T and T, okay? That happens when there's an even multiplicity. So for this little guy here, his solution is 1. He had an even multiplicity. It came down, it touched and turned, okay? The other option, if it's an odd multiplicity, it just crosses right through and keeps going. Okay, it crosses right through. I don't think I have any. Oh, well, here, this guy here. Okay, so for example, this one has a solution of x equals 0. This has a solution of x equals 3. Okay, for this one, this must have had an even multiplicity because look what happened. It touched and turned. This guy would have had an odd multiplicity because what happened to him? It's just crossing right on through and keeping going, okay? So that's just a little example. We're gonna get into a lot of examples of what's going on, but this completes all your information, okay? So here we go. So for these two examples, it says, hold on, I'm blurry. Okay, find the zeros for the polynomial function. So we have to solve it and give the multiplicity for each zero. Then state whether the graph crosses the x-axis or touches and turns. Okay, so 3 items. So this is all about describing what's going on. Okay, so we don't want end behavior right now. First thing we want are the zeros. We want the answer. So he's already been factored for us, which is fantastic. We just have to set every factor equal to 0 and solve. Now, do I need to set 5 equal to 0? There's really nothing to do with that. So he's kind of not really important, right? He was a GCF of 5 that was removed and there's nothing I can really do to him. All right, what would the answer be for this? X equals what? 7, right? You would set that little x minus 7 equal to 0 and solve, you get x equals 7. Okay, what about this guy? What is his answer going to be? A -6. You just would set that little packet equal to 0 and solve and get your zeros. Okay, so we have our zeros. These are called the zeros or the solutions, right? Those are our zeros or solutions. Okay, now we want the multiplicity of each one. Okay, so if I want the multiplicity of each one, now I'm just going to abbreviate here. Okay, but I want the multiplicity of each zero. I'm going to look at the exponent on the packet. That's what I'm looking at. Okay, so I notice for this packet, there isn't anything there, which means there's actually a 1, right? Everybody has to have an exponent. If you don't see it, it's a 1. So what's the multiplicity for x equals 7? 1. It's just the exponent on his packet. What's the multiplicity for negative 6? 2. It's just the exponent on his packet. It's that simple. It's a fancy word that doesn't mean a whole lot of fancy stuff. I know. Okay. The important thing is now we know what happens at x equals 7. Because our multiplicity is 1, that's an odd number, our graph is going to cross. So I'm going to put crosses through. Okay, it crosses through the x-axis. All right. The multiplicity for negative 6 is 2. That's an even number. So this is a touch and turn. A TNT. You can just write TNT if you want to, as long as you know it's a touch and turn, right? Okay, good. Okay, so let's try the next one. That's all you had to do. Is everybody okay with that? So we solved, exponent on each packet. That's what the multiplicity is. Based on whether that multiplicity is even or odd, it either crosses through there or it's a touch and turn. Okay. All right, let's look at this guy here. Yeah, okay. So we need zeros for him. That means we need solutions. We have to solve him. So I don't see a GCF, but I do see 4 terms. We're going to group them. Okay, so my GCF for this is x squared. Okay. I divide out x squared out of both. I get x minus 6. Okay. Let's see. Oh, you know what? What do you guys have for yours? Do you have the same one I have? Oh, you can't even group him. Yeah, sorry. I have him corrected on my paper. I must not have done it on yours. I'm sorry, guys. Let's write a new one that's nicer. Do x cubed plus 8x squared minus 9x minus 72. Sorry, guys. Yeah, do that one. Sorry about that. I just realized I had whited mine out and I never corrected it on your packet. I need to go back in and do that. Yeah, because that is not going to end well. Okay, now we're ready to group. Okay, there we go. All right. So I notice I still have an x squared GCF in the first packet, but if I remove that, I get x squared plus 8 in the first packet. Then I can, what can I pull out in the second packet? A 9. Okay, negative 9. That's okay. All right. Okay. Divide out a negative 9 out of both. That's a 9. Okay. Thank you. Oh, and this is supposed to be x. I'm just screwing up right and left. Okay. Okay. All right. Are we getting there? We're really screwing up the grouping, but the good point is we're going to get the multiplicity right. All right. Now we're going to pull out x plus 8. And we have x squared minus 9 left over. Okay, let's go back and look at our original problem. Our original problem had a degree of 3. How many answers am I supposed to have? 3. Does anybody else see something else they want to do here? No, I want to separate this into x minus 3, x plus 3. There we go. Now we're done. Okay. Everybody okay there? It only took me forever. Okay. So we have 3 little packets. So we need our zeros. So our zeros are going to be x equals negative 8, x equals positive 3, and x equals negative 3. Everybody agree with that? We just set each packet equal to 0 and solved. Okay. Now we want the multiplicity of each. Okay. What's the exponent on every single packet? 1. they're all going to have a multiplicity of 1. What happens at that 0 with a multiplicity of 1? Is it a cross through or a touch and turn? Cross through. Now, for now, that's all you have to write. But let's just think about this. I'm going to draw a little picture of it, okay? Because this is the kind of thing that gets my math nerdiness excited, okay? So now you're done. These are the answers that they wanted for this problem, okay? But if I go back and I think about the original problem, this is my original problem right here. Okay, let's just think about what we know. I know my leading coefficient is positive. So I know I'm going to be rising right. My degree is odd. So it's going to be the opposite on the left. So I'm going to be falling left. This is just me giving you a little picture. Okay. All right. So if I were to graph this, okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay. So if I were to graph this and draw a picture for you, this is what's really going on. I've got an x-intercept at -8, an x-intercept at -3, an x-intercept at +3. I've got a cross through happening at every single one of them. Okay, everybody agree with that? All right. Then I notice I'm falling left, which means he's going to keep on going. And I'm rising right, so he's going to keep on going. Then I have to connect the rest of these. So somewhere up in here, we make a turn to connect to him. And then down in here, we're going to make a turn to connect in him. Where do we make this bottom turn? That would be a y-intercept. So if I plug in 0 for x, I'm making this turn down here at -72. Now, the only thing we can't guess is where this turn is. We don't know, so you have to just imagine it. But this is a picture of this graph. And we did it completely by just thinking about the rules. So, thank you. That is pretty cool for an old math nerd. Hopefully that's, kind of interesting to you guys. Just pretend, just humor the old lady. Okay. Yeah, you're loving it. I know you're taking pictures to share with your friends. Okay. So you know your in behavior, you know your x-intercepts, you know what's happening there. You can even determine where the turn takes place because that's your y-intercept. And then you have the whole thing. Okay. I know. Ooh, oh. Okay. All right. So let's put it all together then. So when you're graphing a polynomial function, you need all the information you can get. So what do we use the leading coefficient test to determine? Yeah, the in behavior. If it's rising or falling on the left and the right. Okay. Then you find the solutions. Those are your x-intercepts. Those are also your zeros. Okay. Then you find the multiplicity of each to determine, does it cross through? Does it touch and turn? You're determining what happens at the x-intercepts. Okay, we're going to use all these steps on the next page to solve the very last problem. All right, then number 3, you plug in 0 for x to find your y-intercept. That's going to help you know where you turn around, where you touch the y. Okay, then you can always determine the symmetry of the graph if you want to. Sometimes students like that, they like to know. So remember, it's even if it's all even exponents with constants, that means y-axis symmetry. It's odd if it's all odd with no constants, that would be origin symmetry, or it might be neither. Okay, and then this is one more little interesting fun fact for you. the maximum number of turning points is one less than the degree of the poly. So if we go back and look at this, degree of my poly is 3. That means this graph is going to make 2 turns. Sure enough, 1, 2. Okay, so it's just a way for you to get a picture. And if you were to graph this on your graphing calculator or Desmos or something, this is what it would look like. Okay. All right, so we're going to put all that together and do page 12. That's our last page of 3-2. Yeah. No, not the whole day. Sorry, I got me too excited. And then we're going to divide. Okay. All right. I know. And then I got excited because you were excited, but I didn't realize you were excited about leaving. I thought you were excited about the polynomial. And then I was like, oh. Okay. Okay, so here we go. We have a nice little poly. We want to know in behavior, intercepts, zeros, including the multiplicity and the symmetry, then graph the function. So this is a MyMathLab problem. Okay, first of all, let's talk about end behavior. Okay, so end behavior. That's our leading coefficient test. All right, our leading coefficient is negative. So leading coefficient is negative. That means it falls to the right. Okay. Then we know our degree is even. So what does that mean? It's also going to fall left. Okay, perfect. So we know we're falling left. We expect 2 lines to come down here to negative infinity. Okay. All right. Then we want intercepts. So intercepts and zeros, right? They're kind of the same thing. We want x-intercepts, which is our zeros, but we want y-intercept also. So first, let's find our x-intercepts. These are also the zeros or solutions. Same thing, right? Okay. So far, we've had some pretty easy little polynomials that we can handle. We can handle him. All right. So if I look at him, he's got a GCF. What can I pull out of him? Yeah, I'll do a negative x squared I could pull out. That's going to leave me with a positive x squared minus 36. All right, am I done? Okay. It's a thingy, so it's a difference of squares. There we go. Okay. Everybody agreed that we're completely solved on that? Okay. All right, now let's solve for those x's. So before we had a 5 out in front here, and we said we didn't have to worry about him because he was a 5. And if you set a 5 equal to 0, that doesn't even make sense. But now we have an x out front. And anytime you have an x out front, you do have to solve it. It's just going to be 0. Okay, it's just going to be 0. Now you could, if that bothers you, do negative x squared equals 0 divided by negative 1, still 0. Square root of both sides, still 0, right? So if you see an x out front, no matter how complicated he is, it's 0. Okay, what's the answer to this guy going to be? Negative 6. And this guy is positive 6. Okay, good. All right. So we have 3 different solutions. Okay. Now, if you go up here, though, how many answers was I supposed to have? Because that's a 4. 4, right? So why don't we have 4 answers? Well, here's 1. Here's 2. This is actually 3 and 4 because he has a multiplicity of 2. So even though we're supposed to have 4 solutions, it's 0. It's plus or minus 0, right? Which is just 0. So that's one of these instances where, okay. So we have a multiplicity for each one that we're supposed to be finding. Okay, so if I go up here to x squared, he's got a multiplicity of 2. That's just the exponent on the x. Okay, what's the multiplicity for both of these guys on their packets? Just a 1. Okay, is everybody okay with that? All right, so let's talk about behavior at these x-intercepts. What behavior has a multiplicity of 2? The t and t. Touch and turn, right? We're going to touch and turn because the multiplicity is even, because it's a 2. All right, what about these multiplicities? These are cross through. Okay, good. All right, now we also want the y-intercept. Okay, so we need to find that. We're just going to plug in 0 for x and solve it. So if we go way back up top, if I plug in 0 for x, what do I end up with? 0, right? So my y-intercept is actually y equals 0, or the origin, right? 0, 0. Okay. All right, the very last thing we want to talk about then, symmetry. Okay, symmetry. So we want to go back and we want to look at this. So I notice that I have even exponents on both. So what kind of symmetry? Am I even, odd, or neither? Even. Okay, he's even since I have even exponents. This means I have y-axis symmetry. Remember, that's written down at the page before, down at the bottom. That means once I draw this graph, I better be able to fold it on the y-axis and it better line up really perfectly. Okay, and then just so we're aware, our biggest exponent is 4. So how many turns is my graph going to make? 3, right? So I should end up with 3 turns since I have a degree of 4. It's always 1 less. All right, well, let's see if we can draw this dude then. Okay, first of all, we're going to put in our intercepts. So I'm going to put in x equals 0, on x equals -6. I think that's -6. And x equals +6. Okay. And this is also going to be my y-intercept right here. Okay. Then let's do end behavior. Okay, so it says I'm going to fall to the right. So your farthest right point is where you're going to fall right. Okay. Your farthest right intercept is where you fall right. It's on -6. No, that's on +6. I'm sorry. The other one's -6. Sorry. Okay. All right. Then on the left, it says it also falls. So that's going to be the farthest one on the left. We're going to fall. Everybody agree with that? Okay. So it told me for these 2 multiplicities, we were crossing through. So that makes sense. We're crossing through. What's going to happen here at 0? Touch and turn. Okay, so based on what we see already, do we think we're going to touch and turn down here? Or do you think we're going to touch and turn up here? How are we going to connect these 2 lines? Does it make more sense to have them up here or to have it down here? Up here, right? Makes more sense to have it up here. That means we're going to be touching and turning up here. Okay. Now, how do these connect? There's really no way for you to tell until you put it in a graphing calculator. So you just connect them the best you can, keeping in mind it should have y-axis symmetry, and it does. You can fold it on the y-axis. It also said it had 3 turns. 1, 2, 3. And there's our picture. So we did it. Okay. Does that sound good? That's okay. All right. But it kind of makes sense how we got it. All right. You don't have to draw anything for the test. It's just, you'll have to identify things on my math lab. So, okay, let's look at this one here then. This one tells us we already have a little graph drawn for us, and we have a window. So remember, this is the x minimum. This is the x maximum. and every tick mark is 1. This is the Y minimum. This is the Y maximum. And every tick mark is 10. Okay, so if every tick mark is 10, I can figure out the y-intercept. It's going to be 0, -10, -20, -30, -40, -50, -60. Okay, so now I can identify that. Everybody okay with that? How I came up with those? I just read it right off of here. Remember, that's what we learned on that first test. Okay, so it says that it's continuous, so it's a poly. We have the end behavior. It's falling right and falling left. Here are the zeros. Okay, let's put those in. 1, -1, -2, -3. It's got a 0 at -4 and a 0 at +2. Okay. Everybody okay with that? Now we're going to go the other direction. So this whole section, we have had the poly and we have drawn the graph. Now, so exciting, we have the graph and you're going to write the poly. Okay, so here we go. We are going to write it as a product of factors. So that means we get to use little parenthesis packets, right? Okay, we want to use a leading coefficient of 1. Now it may be positive or negative. We have to look at our end behavior. And we want to make the degree as small as possible. So that means whatever multiplicities we need, we're going to make them as small as possible. Okay, so here we go. All right, f of x equals, here we go. All right, so we're going to throw a 1 out in front. That's our leading coefficient. But do we need our leading coefficient to be positive or negative? How do we know it has to be negative? It's falling on the right. Does that make sense? If we're falling on the right, it has to be negative. Okay, now we're ready for our packets. We're going to have a packet for every 0 that we have. So it turns out we're just going to have 2 packets. Okay, so let's think about this. It's going to come in handy in the next section. If my 0 is -4, what's my packet going to be? X plus 4. Good. Because all you're doing is adding the 4 to both sides. And this is what you get. And that's what we're putting in the packet. Good. Okay, so if this 0 is 2, what's going to go in my packet? X minus 2. Okay, good. Now we're not done. All right. I noticed that there's a touch and turn at each of these. So if there's a touch and turn at each of those, that means my multiplicity is going to be what? Even multiplicity. 2, 4, 6, something like that. Now this wants us to pick the smallest one. So what's the smallest even number we can use? 2. There we go. Okay, now we're not quite done. All right. We're not quite, no, we don't have to distribute, thank goodness. We did end behavior. We did zeros with multiplicities because they were touch and turns. This little guy right here hasn't been handled. Your y-intercept has not been handled. All you have to do for him is stick him on the back. Minus 60. This is your poly. So let's check him and make sure now, because he's falling on the right, but we never checked to make sure he would fall on the left. So to fall on the left, he has going to have this an even degree. Okay, so 2 plus 2 is 4. That's even. So sure enough, same behavior on the left, and there it is. So all you have to do for your y-intercept is add it there on the end, and then you're all done. Now, if you don't want to put the -1 out there and you just want to do a negative, of course, you're welcome to do that. That would be really great also. Okay. All right, let's talk about page 13. That doesn't mean pack up while Miss Holcomb talks, because we have 6 minutes. I'll make you do a problem if you do that. Okay, so real quietly flip it over and just sit there. That's right. Okay, Ted got me all fired up. Okay, all right, here we go. All right, so if you have noticed, so that's really everything we're going to learn about polys. But if you've noticed, every time we've had to find a zero, every time we've had to find solutions, we've been able to do it. They've been pretty easy. Well, your days of quadratics really are kind of fading away the higher you go in math. So we are going to need a way to handle really complicated polynomials. And we're going to baby step into it. In section 3.3, I know you've all had before, it should be completely old news, repeats. But I also have noticed there are really big gaps in who remembers how to do synthetic division and who doesn't. I also think there's a teacher out there somewhere. I don't know what school they're at or what grade they teach, but I think they're traumatizing synthetic division students because some students are all about it. And some students are like, they like cower, like they're going to be beat. So it's really easy, right? And we're just all going to be okay with it. We're going to learn it from the get-go in next class. But here's what we're going to talk about for division. We don't do long division in college algebra. Now, you will need to do long division if you go on to dual enrollment pre-calc or dual enrollment calculus, but you don't have to do it in here. We're only going to do synthetic division, which means 2 little terms in the bottom. That's it. Okay. If you would like more information about long division, you can look on your ebook on my math lab. Okay. But so for synthetic division, you're going to have a nice poly that has to be in descending order. Then you're going to have a nice little divisor down here in the bottom that you're going to divide into it. It has to be 2 terms, and the leading coefficient has to, the degree has to be 1. Okay, degree has to be 1 and just 2 terms, and that's it. Okay, so section 3.3 is very short, and we're going to cover that Thursday, and we get to stop there. So you get a little bit of a break.